continue the ruminant digestive system. Yesterday we have done part of it, and today we'll continue with the remaining few of the slides or the things need to be learned. And yesterday we were talking about the rumen microbes, where in which the more than 200 species of the bacteria will be there, and many subspecies are there in the rumen, and the 25 species at concentration more than 10 raised to 7 per ml, and 10 raised to 10 to 12 cells per ml are also there for the other species, and the 99% of them are the obligate parasites, means they are dependent on the other sources, especially on the cattle. So the environmental niches, especially for the bacteria flora, are also very important in the bacterial digestion, and these are the free living in the liquid phase, which is provided by the animal and loosely associated with feed particles. Then firmly they are adhered to the feed particles and followed by the rumen epithelium. They will be adhering to the rumen epithelium like this particular thing, and attached to the surface of protozoa and also the fungi. And here you can see that the bacteria are attached to the straw in water buffalo rumen. This is the electron microscopy photos. So the benefits of the bacterial attachments are many more are there, and always bacteria they colonize the digestible surface of the feed particles. Then they bring the enzymes from the microbes, which are freely floating in the rumen, and also from the substrate of the feed stuff. So they are together, they will be together, and at the same time they protect the microbial enzymes from protease in the rumen. So these are the benefits of the bacterial attachment, and if attachment is prevented or reduced, the digestion of cellulose greatly it get reduced. So the retention time of the microbes in rumen is increased through prolonged digestion, especially reduced predatory activity of the protozoa, because protozoa are the one which are going to consume the bacteria and live. Then overfeeding of the fat to ruminants can coat forages, reducing bacterial growth. So more and more fat content should not be fed to the ruminant. That's what the benefits of the bacteria may get reduced. And another thing is the microbial populations. Then the cellulolytic bacteria are also called as the fiber digesting bacteria, cellulolysing bacteria. And apart from this one, these bacteria require the pH of 6 to 7, and they are very much invested in the digestion of the cellulose and also the both the hemicellulose. So they utilize the nitrogen from ammonia. So this is the thing, and they require the S or sulfur for synthesis of the sulfur containing amino acids are present. Then they produce acetate, propionate, and butyrate, or the volatile fatty acids to some extent with carbon dioxide. So they predominate in ruminant of cows and fed referred to the diets, especially the cellulolytic bacteria, and they are the important in case of the fiber digestion. So next is the aminolytic bacteria are there. Many amylolytic bacteria are there, and they are also having lot of importance to digest starch and sugars, because it is not a difficult task to digest the starch, and requires the pH of 5 to 6. Then utilize nitrogen as ammonia and peptides, and produce propionate, butyrate, and lactate. All these three things, and they are predominant in ruminants and feed grains diets. So the rapid change in the grain diet causes the lactic acidosis, and all these are suddenly they are going to die. So lactic acidosis is the one which is one of the most dangerous thing to the ruminants are concerned. Hence, it should not happen, especially in case of the cattle is concerned. Then, the methane producing bacteria are also important bacteria which are going to produce the methane, or what we call as the gobar gas, and this methane is utilized by the microbes for energy synthesis. Then they represent loss of energy to the animals released by the eructation, especially the methane is a gas. Also, it's known as the greenhouse gas. Then later we can also digest the starch and cellulose. Of course, the cellulose. Then many times the cellulose digesters are cellulose digesters. They are the cellulose digesters, and they produce methane. And at the same time, these are going to cause the global warming, especially the gases which are produced by these organisms is it will be released to the circulation. Then microbes. Then the second category is the protozoa, and they are starting from large, then starting from 20 to 200 microns, and unicellular organisms. They ingest bacteria and feed particles. Then they engulf feed particles and digest carbohydrates, proteins, and also the fats. And there are numerous type of such bacteria are there, and many of them are especially uh, are involved in utilization of the feed particles, especially. So this is the microscopic picture of the microorganisms or the protozoa attached to the red clover. Here you can see that this is red clover, and after feeding, so they need to be attached to the food particles, then they get digested. Then the dietary factors that reduce microbial growth is the rapid or dramatic changes like the sudden change in the pH, sudden change in the feed, restricted amounts of the feed, excessive unsaturated fat, and bacteria do not use fat for the energy. Then they inhibit fiber digestion, and different types of the fats have been different effects may be present. Then dietary factors that reduce the microbial growth are excessive non-structural carbohydrates like whenever there is a lowered rumen pH, slug feeding is there, then rumen acidosis may also happen. Then this lead to the acidity, gastric acidity is always it is going to be caused. So to prevent acidosis, then one must balance lactate users and producers, so too much acidity is also not required. Then dietary factors that maximize the bacterial flow. Suppose if you want to make more and more bacterial growth, then you need to administer more and more dry matter, means the fodder, especially the fodder or the roughage, what we can say. So if you increase that thing, then always there will be increase in the population of the bacteria. That's what the science says. And the balanced carbohydrate and protein fractions at the same time need to be done for the optimum growth of the bacteria. Then energy and nitrogen need to be balanced very properly. Then gradual ration changes, especially for the ruminant, sudden increase or decrease or sudden change will always reduce the digestive process. So gradually it has to be done. Whereas the feed available all times should be there, and the pH of the rumen need to be maintained always. Then here you can see that there is a curve versus the time, and the frequently of feeding or total milk ratio TMR. So as we go on feeding the animal, then the rumen pH also changes. So if you feed twice daily, then frequent feeding or TMR always it is better. Means if you are going to feed the animal only once, then there will be rumen overload. So instead of that thing, we can have the persistent feeding so that the rumen pH is maintained in a uniform pattern. So the rumen function as a overview, everyone knows. So carbohydrates enter inside the rumen in the form of the cellulose or also the simple sugars like the starch and other thing. Then the crude protein also enters. Then fat also enters. Whereas lot of microorganisms will be present already there. Then the material settles down. Then the degradable protein, rumen degradable protein will undergo the rumen degradable, whereas the rumen bypass protein will directly go to the abomasum. So the microproteins, so undegradable proteins are always entering the abomasum. Then the bacterial microflora or the flora they convert the starch into acetic acid and butyric acid, propionic acid, and these are called as the VFAs, volatile fatty acids. So all these will enter the liver, then there the glucose is being converted, and ultimately the intestine is going to absorb the crude protein. Then several digestive enzymes will act in the rumen to digest the protein into polypeptides, then into amino acids. So ultimately, the glucose, then the amino acids, required amino acids, and also the fat, they will be coming into the udder for getting the milk. So the amino acids, fatty acids, minerals, vitamins, and also the water. So they form the formation of the ultimate food, that is the milk. So this is the process how it is going to happen. So the ruminant digestive system, especially about now, 193 species of the ruminants are existing in this earth, and among these the six families are there. Then they are called as the antelopes, then bovidae, cervidae, giraffidae, Moschide, then Triangulate. All these are six families are there. The number of wild ruminants is 75 million today. 75 million. Then domesticated is less. So these two figures one need to remember. 75 million is a huge number compared to the domesticated 3.5 billion. Of course, it's a billion. 3.5 billion and 75 million. So please read this sentence properly as per the Hoffman of this page. Approximately 75% of the population of the domesticated ruminants constituted by cattle, sheep, and goats, all of them belonging to the family Bovidae. Okay. So here, so many families are already there. Uh, Ante, Bovidae, Cervidae, etc. Then Cervidae is the sheep and goat. And cattle and sheep are the most numerous species, and cattle is of most economic importance, especially in India is concerned. Apart from the sheep and goat are also there, but in India it is one of the important species. Then here is the digestive system as we have already know. Rumen, reticulum, abomasum is there. Then these are all the systems which are very much required. Then the food is engulfed inside the rumen. Then it goes to the lower side here. Then it enters the lower side of the rumen. Then once again, it is regurgitated back, then masticated, then re-swallowed, then it enters the abomasum, then intestine, then the duodenum, intestine, etc. So, rumen is a very big fermentation vat. So the digestive process is little bit characterized by anatomical adaptations to digest fibrous material. No animal can do this thing. And also they can digest the cellulose and other materials, the complex carbohydrates. So the property gives them the advantage of over the non-ruminants because non-ruminants only can digest the simple carbohydrates. So an important characteristic of the ruminant digestive system is the concurrence of microbial fermentation. It's always microbial fermentation is one of the important thing, and the digestive system is consisting of the symbiosis, especially symbiosis of the ruminant with that of the microbial population. So the microbial fermentation occurs mainly in the rumen. It's a very big vat, and apart from this one, the four other compartments like the stomach, which consists of reticulum, omasum, act as filters, and abomasum, the two glandular stomach. Here you can see that the stomach is having such things, especially this is a very big vat and that's called as the rumen. Then the second is followed by the reticulum. Then the third, a small organ, it is known as the omasum or the stomach with lot of pores. And ultimately, the fourth stomach is the abomasum. Then after abomasum, you can see that the intestine starts and small intestine. Then it is going to join with that of the large intestine. Then large intestine makes the ileum, rectum, cecum, and the colon. So colon is the end part, and cecum. From the cecal digestion is also present in case of ruminant. Ultimately, dung is voided through the reticulum. So starting from the esophagus, it is going to end with that of the rectum. So the esophagus is always involved in erectation of the methane gas, which is produced, enormous quantities produced in the rumen due to the fermentation process of the carbohydrates. Then lately it is going to end up with that of the abomasum, then small intestine, large intestine, the ileum, cecum, rectum, and colon. So this is also another structure. Of course, the food is bidirectional. This is the only animals in which the food moves bidirectional. The number one is swallowing, then regurgitation. So the rumen, then reticulum, omasum, then abomasum, then through the intestine it is going to pass. Hence, the ruminal function is contributed by both sympathetic and parasympathetic nervous system. Then the fermentation initially results in the degradation of carbohydrates, protein into short-term intermediates such as the simple sugars and the amino acids. Sugars and amino acids. Ultimately, this is the product. The products of the critical degradation are basically they are converted to carbon dioxide, then methane, ammonia, and VFAs. So the VFAs are volatile fatty acids are acetates, propionate, and butyrate. So to lesser degree branched the small VFAs and occasionally sometimes the lactates are also produced. So here energy efficiency conversion is there. For example, the acetic acid is going to have 419 kilocalories and it's contributing to 62% of the energy requirement. 1 mole is equal to 600 kilocalories of the energy from the glucose and propionic acid. So the VF is 734 kilocalories, it is 108% of the total energy requirement. Then the butyric acid, 524 kilocalories, it is 78%. So different type of these volatile fatty acids are contributing in a different pattern. Then the rate and extent of the fermentation, especially in case of the this especially apart from this one, the protein, vitamins, short organic acids, all these are produced. And ultimately, they are ending up with the milk and meat, especially in case of the smaller animals. So ruminant animal derive about 70% of their metabolic energy from the microbial fermentation and remaining from the regular fermentation or the digestive system. And microbial protein accounts for 90% of the amino acids reaching the small intestine, and remaining just 10% is from the other type of the what we can say. So here you can see that the ruminants are the one which are going to have the digestion in grass-eating animals. Unlike humans, all these things are have a special stomach with all these animals, they are having the four stomach, and digestion in grass eating animals is a very special process because the animals are having the what you call as the mastication process. So they contain reticulum, omasum, abomasum, rumen. So whenever the animal eats grass, then directly it goes to the rumen, then it get stagnated there. Then later what happens is it is regurgitated back. You can see here it comes to the esophageal sphincter, and once again coming back, and the animal starts mastication here. So two times it is bifacing. So whenever the mastication is there, it once again enters the reticulum or the omasum. So this is a very characteristic feature of the animals are concerned. Hence, one need to know, especially this process is one of the very interesting thing, especially the rumen, reticulum, omasum, and abomasum. And ultimately, the food particles are passed into the small intestine, then large intestine, then also the cecum, then also the large intestine, then rectum and colon. So once again, in case of the cecum, the microbial digestion is always there. Then that's the end of the ruminal digestive system, and we can see that the polymers yesterday we have seen all this how the glycolysis is going to take place, and acetate, butyrate, and propionate are the end products of the ruminal digestion. Then the methanogens are also present, which are very much important for that of the digestion. Then this is also another thing where in which the ruminal digestion take place, especially in case of the ruminant, and in case of ruminants, the bacterial viability will be there. Then the in the rumen there are bacteria, fungi, then small and big fungi are also there. Then they produce vitamins, enzyme, and minerals. Then in the intestine, production of the compounds with antibacterial activity may also be there. And ultimately, this is the specificity of the ruminant digestive system. Then the rumen has complex environment of the bacteria. Bacterial environment is there. Then if we count the bacteria population, it is about 10 raised to 10 to 10 raised to 11 cells per ml. More than 50 genera are there. The ciliate protozoa are there. Then they are accounting to 10 raised to 4 into 10 raised to 6 per ml, and 25 genera of the ciliate protozoa are there. Then anaerobic fungi are also there, which are about 10 raised to 3, to 10 raised to 5 zoospores, whereas the bacteriophages are there about 10 raised to 8 to 10 raised to 9 per ml and per ml. So the highest number is the bacteria, and there will be very huge population of the bacteria are there in the ruminant digestive system. So here you can see the photo of certain bacteria, rumen protozoa, and you can easily see. Suppose if you take a rumen liquor and examine it in the microscope, you can see the movement of rumen protozoa. Then varieties of the rumen protozoa are present in the rumen liquor, and they will be floating, they are flagellated, they are ciliated, and many more. Then the protozoa, then bacteria, and fungi, they are living together, and protozoa are having the highest size. Here you can see this is the biggest size, and followed by the fungi is also the next highest or bigger size, whereas the bacteria is smaller size. So all these will be floating in the rumen, and they adhere to the fibers, then get digested. Then here also you can see that the grass is consumed by the animal through the esophagus, then goes to the rumen, then also the omasum, then reticulum, then regurgitated back, once again found pushed back to the rumen, later passes into omasum intestine, then also the rectum. So plant material is undergoing to the bacterial digestion especially, then produces the carbon dioxide and water. Ultimately, the methane gets out of the bacterial fermentation. Then also, it is the same in case of a sheep. Then the feed related changes may also enter the population of the bacteria. Then apart from this one, the crude protein, cell solubles, fiber fractions, and the short chain fatty acids and acetate propionate ratio, which will also make the chain. And the gas produced is the methane. Of course, the carbon dioxide also, whereas the rumen microbes are belonging to different species, Clostridium and Coccidiosis, the Streptococcus and Fibrobacter. Then rumen related changes are always the mean retention time in the rumen, then pH of the rumen, and the nutrient absorption is also there. Then rumination time is how much time is spent for rumination, then the how much quantity of the VFAs are produced, then microbial protein, non-microbial proteins. Then all these are influenced by the change in the ruminal pH. So here we can see that several parameters are also there, that the microbes do have antagonism, then synergism process in the rumen, then bacteria in number are highest and dominant role, then they are adopted at the pH that's ranging from 5.5 to 7. And even in the absence of the oxygen or anaerobic situation, the temperature inside the rumen is always, it is counted as the 39 to 40 degrees Celsius. So in the presence of the moderate concentration of fermentation products, so they are going to release several type of liquids. So rumen digest volume accounts for the 8 to 14% of the body weight of the cows. Ruminant digesta. So the content of the rumen will be about 8 to 14%. Then the content, and it is characterized by intake of the dry matter, then content is about 15%. So suppose a cow is weighing about 100 kg, then if you take the average of that thing also, then 10 kg will be the ruminal content, and if it is 300 kg, then 30 kgs will be the dry matter content will be present in the ruminants. So there are major in vitro digestion techniques currently available are the nutritive value of different feeds analysis, Digestion with rumen microorganisms. It's the number one process. Digestion with rumen microorganism is one of the process as per the Tilly and Terry. And digestion with enzymes. Second one, in situ the nylon bag technique. So these are the three different techniques how the digestibility of different feed ingredients are being calculated. So the nylon bag technique is in SACO has been used for many years to provide the estimates of both the rate and content of the disappearance of feed constituents also there. Then those characteristics are measured by placing feedstuffs in the fabric bag and then incubating the bag inside the certain time interval in the rumen of the animal. Then the rumen digestibility of feed is influenced by different components of the feed and also the digestive process and physiological status of the animal. And here you can see that the digestion of the polysaccharides, cellulose, especially hemicellulose, pectin, and starch. This cannot be digested by the monogastric animal. So there are varieties of the hydrolytic species of the bacteria are there, and they convert them into the soluble sugars. Then hydrolytic fermentable species of the bacteria they will act, and intermediary compounds will definitely act, and the products produced are the pyruvates, then lactate, then ferment and succinate. And from this thing, the volatile fatty acids are produced: acetate, butyrate, propionate. So the methanogens are the bacteria which produce methane and carbon dioxide, and these will be erected out, especially from the esophagus. Then, coming to the different classification of the ruminant feeds, carbohydrates are the important source of the diet of a ruminant, and they are classified into the cellulose, then hemicellulose, etc., then starch. So they account up to 70 to 80% of the diets of the cattle, and the cattle have got the tremendous energy or capacity to convert the carbohydrate into the protein source, and they are all monomers or polymers in nature. So the carbohydrates are broadly classified as the non-structural that are found inside the cells of the plant and structural that are found in the plant cell walls, but fractions are chemically uniform. So apart from this one, the carbohydrates are including organic acids, then mono and disaccharides, oligosaccharides, starches, other reserved carbohydrates. So the non-structural carbohydrates include the pectin. It is referred as non-fibrinous carbohydrate and calculated as 100 minus good protein plus ether extract plus ash plus NDF. Then non-fibrinous carbohydrates are highly digestible and are the major source of energy for the high producing cattle. Then the fraction of structural carbohydrate is characterized by neutral detergent fiber, that's the NDF, and acid detergent fiber, ADF contains. So NDF includes the cross-linked matrix of the plant cell wall with cellulose, hemicellulose, lignin as the major component of the ADF, especially acid detergent fiber and neutral detergent fibers. So both of these things, acid detergent fiber, neutral detergent fibers, and cellulose are measured according to the method described by the one sourcest. The contents of hemicellulose is calculated by NDF minus ADF. So one need to know, especially this thing need to be known from the people, especially some of the time. And here the rumen is always an organ which is having the slow movement. So it is usually 2 to 3 per minute. So usually the upper part is containing the gases, and here you can see that the gases are erected out during the process of the rumination. So, hence, the rumination process is one of the complicated process, but it is very useful for the production of the different products. Then, degradation of carbohydrates by ruminant microflora ecosystem. Then, there are always the microbial digestive system, and we have all talked about this particular thing. The individual carbohydrates characterized by faster rumen degradation results in greater microbial yield. The enzymes, then we are going to continue with that of the thing. Then this especially the digestion of the carbohydrates is also another factor in which we are going to get major energy sources. So nearly all the, especially the all the carbohydrate digestion within the rumen, but under certain circumstances, the significant amount of the carbohydrate digestion can occur in the small intestine also. Whereas this is the process in which the especially cellulose, hemicellulose, then protein digestion, proteolytic bacteria are there, then cellulose digestion by the cellulolytic bacteria. So they will get absorbed into the blood vessels. Then the lipid digestion, they get esterified plant lipids, saturated plant acids, then absorption of cholesterol by the cells. So this is the way how the feed is acted upon by the different flora, especially the ruminal phase. Then there are fibrolytic fungi, fibrolytic bacteria break down the beta linkage will be present. Then the volatile fatty acids are the sources of the glucose. Then bacterial proteins are produced. Then peptides. Then esophagus. Then mouth. So non-fibrinous carbohydrates may account for to the extent of 40 to 45%, especially in case of the diet. And NFC fraction is considered a source of readily available energy to the bacterial growth. So mono and disaccharides are also going to be participated. And yesterday we have seen the glucose fermentation process is also one of the important process of the bacterial digestion. Then here you can see the different type of the bacteria, how they are important, especially the Staphylococcus bovis is then the important species are the Ruminococcus albus, then Prevotella species, and many more species are there. So, including the regular Streptococcus bovis also, Lactobacillus ruminis, and many more. So the another thing with maltose utilizes the Ruminobacter amylosis, and oligosaccharides are digested by Actinomyces ruminocola. So these are all the bacterial species. Of hundreds of the bacterial species are present, especially in the rumen, reticulum, esophagus, omesum, and everywhere they are present. And once again, the number of the bacteria which are present in the ruminant is depicted here. Highest number is the bacteria, followed by the protozoa, followed by anaerobic fungi, and lastly the bacteriophages. Then the roughage fiber is being attached by the ruminal bacteria or protozoa and fungi. Then they are going to be degraded by the microorganisms because of the pH. Then the microbial protein digestion can also take place. Then starch digestion is also once again a microbial digestion system like the amylase, starch, amylopectin, then maltose and maltodextrins are digested by the ruminants to produce different entities. Then carbohydrates are divided as soluble, then the fiber cell walls, then the NDF and ADF. So the soluble carbohydrates are the sugar, starch, pectin. So they are having 95% to 100% digestibility, whereas semicellulose is only 20 to 80%, cellulose 50 to 90%, medium to good digestibility, whereas the lignin is not digestible, it is very poorly digestible, and the all others they are the energy sources for the animal, whereas the lignin is not such thing. Whereas the neutral detergent fibers, they are all digested. Whereas the ADF, acid detergent fibers like lignin, it is not digestible properly. And here is also another same thing, rumen, then the methane is evacuated out, then also, so coming to the digestion, once again it is remaining the same, so we'll skip it to the next slide. So digestion, absorption, glucose, intestine, the same thing is there. Cellular digestion takes place to the greater extent, especially in the ruminants. Then apart from this one, the new things what we can learn here is protein digestion, amino acids are converted. Fat digestion, absorbed or the lipid are there. Whereas the carbohydrates, volatile fatty acids. These are the simple three things which we need to convey this particular thing. So these different type of the bacteria are present, especially the Fibrobacter succinogens, then Ruminococcus are there, then Flavisuccus are there. Then these species gain selective advantages in the rumen and is by optimizing two carbolic acids, cellulose, carbohydrate deprivation, etc. So the rumen digestion takes place at different places. Then fibrobacter, there are the photos of certain bacteria present here, which are contributing to the especially digestive process of the different types of the. So coming to the different bacteria there. So this is Ruminococcus. So this is microscopic or sometimes the diagrammatic representations are also there. Then the hemicellulose is also digested, and we know already the process how it is xylans, xyloglucans, mannans, and mixed with beta glucans. So hemicellulose is digested to the extent of 16 to 90% depending upon their composition. Then lignin is the one, it is lastly digested. So it's a complex phenolic polymer. Then it has got the strong covalent bonds between the lignin, etc. Whereas the interaction between energy and protein metabolism is there in the ruminants. Hence, there is the energy is converted to protein, and protein, whenever it's required, it is converted to energy. So here you can see the rumen digestion is a process in which the rumen degradable protein and rumen undegradable proteins are ultimately they need to be converted to the different type of the amino acids. Then they need to be secreted in the milk and also the body tissue. Then a ruminant will eat grass and convert it into the, especially in the ruminant phase, then the intestinal phase, to the different required amino acids. Then synchrony hypothesis is one of the hypotheses is there. That's called as the purpose of proper nutrition is nutritional synchrony refers to the provision of dietary protein sources, true protein and energy. So ruminally fermented carbohydrates to the rumen such a manner that they are available to the ruminants especially. Then synchronous nutrition availability should allow more efficient that of the use of the intestine, thus enhancing the production of microbial products, increasing nutrient supply to the animals also. So the production efficiency of a ruminant is depending upon the nutritional synchrony, means all need to be produced in a synchronous manner. So there are results which confirm increase in the yield of the microbial protein when highly degradable carbohydrates are synchronized with rapidly degraded protein. So this is very much required for the feed formulation is concerned. Then the fundamental reasons of the is ruminant is a one animal which is able to recycle the nitrogen from the blood and saliva to gastrointestinal tract during the period of dietary protein deficiency during the periods of asynchronous carbohydrate and protein supply. So that's why the nutritional synchrony means conversion of carbohydrate into protein and vice versa. Then milk fat provides here the 30% of consumed humans and is the richest natural dietary source of the fatty acids especially. So the research undertaken ever the past decade is indicated that the concentration of the favorable fatty acids is in milk may controlled by the starch, etc. Then pollution emission is another thing. Usually the pollution is in the form of nitrogen and methane. They are produced from the ruminal microbial fermentation. Then the contribution of methane is up to the extent of 5 to 12% of the gross energy here. Then estimated about 15% of total atmospheric methane emissions. Only 15%. The remaining thing is from other sources. So if we properly mix the carbohydrates ration, structural and non-fibrinous carbohydrates, then carbon dioxide, etc., may be less produced. So the cow rumen is producing the methane to the greater extent, and that's called as the greenhouse emission or economic sector. So here you can see that 90% of the methane is from the erectation and 5% is from the dung. And if we compare to that of the total greenhouse effect, then here you can see that the sources, which is electricity and heat production source, is about 25%, whereas the forestry and other land use about 9.6 to 10%. Then other energy source is also 96%. Then 21% is from industry. Then 14% is from the transportation, whereas 6.4% is from building, whereas the 3.7% is cow births, especially, whereas the cows are contributing to the extent of 9.4% only. Hence, one need not bother, especially to the extent of the uh, especially the animal produced methane here. The total production is about 15% only here. Or if you total it, then 14.5%. So 0.6% poultry, small ruminant, 0.9% chicken, 1.2% buffalo, 1.2%, 1.3% is from pig, and 9.4% is from cow. Then 3.7 is from cow buffs. So totally contributing to the 14.5% also. So when compared to the industry, then transport, then electricity heat production, it is very less. At the same time, very much useful to the farmers. Hence, one need not have any one of the problems like the especially the greenhouse effect, especially from the ruminants are concerned. And the ruminants are the one which are the always better animals which contribute to the especially the veterinary, etc. So The cows, are they going to contribute to the global warming? Yes, of course. But how much? It is just 14.5% or maximum it is 15%. So total, if you come to the industries are contributing to the extent of 21%. Coal mining 10%, landfills 18%, enteric fermentation of the ruminants is 6%, natural gas and petroleum 29%. So total methane in the US, especially, this is up to 26%. Whereas methane emitted per animal per year is cattle 265 pounds or 120 kilograms per year. Then the sheep 8 kgs, goat pigs 1.5 kgs. Of course, the human is also going to the about 120 grams per year, especially the copper. And natural occurrence is here you can see that the production from ocean water is also there, and methane hydrate, gas production, coal mining, all these are going to produce, and it is very very less when compared to the natural emitting. So this is about the thing which need to see, especially the ruminants, how they are important, and also how we can use the ruminants for the betterment of the economics of India is concerned. And many times the experiments are also converted using the cannulated animal, rumen cannulated animal. So a particularly the surgery is conducted and a plastic chamber is fitted or the valve is fitted, then directly the rumen liquor is taken out from the cannulated animal. Once again, after taking out, it is going to be closed. Then the rumen liquor which is collected will be sieved properly using the sieve, and later it is used for different laboratory tests and feed analysis and other different type of these studies. Of course, whenever the animal is suffering from the anorexia, the rumen fluid will be pumped from a bucket using a simple equipment passing a stomach tube inside the mouth of this particular animal. And here also you can see, and many such equipments are also available in the market, and we can make the utilization of such things for the rumen indigestion. Many times the animals become very much anorectic, and at the same time they become totally lousy or sometimes morose. Hence, we need the rumen environment to be corrected very properly for the proper digestion and also the production of the energy, or else it will end up with the metabolic acidosis and sometimes the ketosis, also sometimes the different metabolic disorders, especially the ketosis, and the prolonged ketosis leads to the acidity, and also sometimes the prolonged acidity may also end up with the ketosis. Hence, one need to use the ruminants in a very proper thing so that these creatures, the wonderful creatures in the earth, which convert the highly unproductive fiber or waste product into the very good commodities like the milk and meat, they need to be taken care very well, especially these animals are sacrificing their life for the betterment of the human life. Hence, the human digestion is one of the wonderful things that we need to understand properly. And of course, for hearing, I thank you very much for the patience hearing till date. Thanks a lot for everyone.